Ciao Am. So, I know you haven't seen a video in a long time, and hopefully you enjoy this. So, we're going to do something a little bit differently now. We're going to talk about conceptual understanding, and when you're in class, you're actually going to do more problems and harder problems. And hopefully, this will actually, I feel like I have a good feeling about this. So, today, what are you supposed to be learning today? Today, you're going to learn about adding rational expressions. So adding rational expressions. So let's talk about the concept, because you all know how to do this already. You all know how to do this, but you just have to understand how to do this. So please pause this, and can you subtract these two fractions together, please? So just pause it, give it a try, and unpause it when you're done. Alright, good job. So a couple people did this. They go, okay, I need a common denominator, so I'm going to find out what is common between 6 and 4. So some people say 24, some people say 12. 12 is actually a better number because it's smaller and you don't have to reduce at the end. So what did they do is they multiplied the top and bottom by 2 to make 12. That makes 10 over 12 minus, over here they multiply the top and bottom by 3 to make 12. 3 over 12. 10 over 12 minus 3 over 12 is 7 over 12. And that's your answer. Good job. They taught you how to do this. And it's easy if you could find the common denominator. If you could think about it and go, I know what the common denominator is. But it's difficult when the problem is more complex, when you're doing with rational expressions, and the common denominator is not as obvious. What do you do in that situation? So you have to go back to the basics, back to the idea, the concept of what you're really doing. What you're really doing to find the common denominator is you're really factoring. Let me show you. Go back to this problem. I factor. Do I care about the numerator? No. I just care about the denominator being the same. This becomes 5 over 6. Break down 6. What two numbers multiply to be 6? 2 and 3. Anything else? No. Minus, the top is 1 over 4. What two numbers make to be 4? 2 times 2. And this is what I do. It's called jealousy game. And this is what happens. I thought about this when I was thinking about my little cousin. Because my little cousin plays with other people. And then they see that and he comes home and goes, oh, can you buy me an iPad? Can you buy me an iPod? Can you buy me a toy? Can you buy me something? Like, where does he get all these ideas from, you know? When I was younger, I never asked for an iPad or iPod. Maybe because they weren't invented yet, but still, you know where he gets these ideas? He sees his friends have it. He goes, oh, why does he get a toy truck? I want a toy truck too. Why does he get an iPod? I want an iPod too. So basically, these are kind of like jealousy. What he has, I want. What my friends have, I also want. So this is what you do. You look. The green number has 2 and 3. The blue number has 2 and 2. What does the blue have that the green doesn't have? He goes, oh, why does he have 2 2s? I want 2 2s. So he goes, Mom, Dad, he can have another 2. Great. He gets another 2. Does the blue number have anything that the green number doesn't have now? Nope. So now the blue number looks over there and goes, what does the green number have that I don't have? Well, the green number has a 2. I have a 2. I don't care. The green number has another 2. I have another 2. I don't care. The green number has a 3. I don't have a 3. So I go to my mom. Mom, can you give me a 3? When you multiply a fraction, you have to multiply top and bottom. When you multiply a fraction, you have to multiply top and bottom. And take a look. What you just did is found the common denominator. You're going to be doing this with numbers too. How do you feel so far? Good? Excellent. So over here, the top becomes 10. The bottom becomes 2 times 2 is 4 times 3 is 12. Over here, the top is 3. The bottom is 2 times 2 is 4 times 3 is 12. Look at that. They're the same numbers. 3 minus 10 minus 3 is 7 over 12. That's it. How do you feel about the idea, the concept behind that? Good. Excuse me. Alright, let's take this and move it up just a little bit and see if you can figure this out. First of all, pause it if you think you can, and then try it. Then check and see if I could do this. If you could do it the same way I did it. Alright, breaking it down. Let's break down 2x squared. Break down 2x squared. The top becomes, the top is still the same, 3. The top is still the same, 3. The bottom is 2x squared. That means 2 times x times x. plus, the top is still the same, 5. The bottom is a little bit different. I have a 2 times 3 times x. Any questions how I got those? Obviously, you're not going to ask me now, but write it down. All right, now, what does this have that I don't have? Does it have a 2? Do I have a 2? Yes. It has a 3. Do I have a 3? No, so I want a 3. It has an x. Do I want an x? No, because I already have one. When I multiply top and bottom. Over here, does the same thing. 3 I have, 2. Do I need a 2? No, I have one. How about an x? I have one. How about another x? I don't have that, so I need another x top and bottom. Simplify. This becomes 9 over 2 times 3 is 6 times x is x squared. So 6x squared plus top becomes 5x over 6x squared. Take a look. The denominators are the same. Wow. You just found the common denominator. Exciting? Very good. Add the top becomes 5x plus 9. The bottom stays the same, 6x squared. Can I cancel the x and the x squared? No, remember, multiply cancels with division. There you go, done. Is that it? No, hopefully you said no. You have to write restrictions. What can't the variable be? The variable cannot be 0. Ta-da! How do you feel? Good? Alright, excellent. Moving on. Let's look at this one. This one's a little bit difficult. First things first, I always recommend doing this when you see a negative. You see this minus sign right here? What I like to do is I do this. I change it to a plus, and I distribute the negative. Everyone see what I just did? I change it to a plus, I distribute the negative to the top. It will save you a lot of problems in the end, because sometimes you go minus, am I supposed to distribute, am I not supposed to distribute? If you just change all your negatives to be a plus and distribute the negative in the top, fix all those problems so you don't have to worry about the end. Alright, let's look at this. Over here, we have a 3. The bottom, we have an x squared minus 4, but we want to break it down by the factors. What makes x squared minus 4? Very good. X plus 2, x minus 2. Oh, and please feel free to go ahead if you think you understand this and you know how to do this problem. Plus a negative 5x plus 1. I distribute the negative on the top. At the bottom, what are factors of x squared minus 6x plus 8? Take a look. That is x minus 4, x minus 2. Alright, jealousy. What does that guy have that I don't have? Do I have this? No, so I want it. I want an x minus 4 top and bottom. Do I have this? Yes, I do. It's right here, so I'm good to go. Now the other guy. Do I have this? No, so I want that. X plus 2, top and bottom, has to be the same. Do I have this? X minus 2. Yes, it's right there. Therefore, now we have the same denominator. Multiply the top becomes, distribute. Don't forget to distribute. 3x minus 12 divided by x minus 4, x plus 2, x minus 2. Do I have to multiply the denominator out? You don't have to. Plus, actually I prefer you don't. Over here, distribute. This becomes negative 5x squared minus 10x. Now the 1 plus x plus 2. The bottom stays the same. X minus 4, x minus 2, x plus 2. Look at this. The denominators are exactly the same. Perfect. Now all we have to do is add the numerator. 3x, and first of all, is there any 5x squared here? Is there any other x squared? So you know that 5x squared doesn't combine with anything. The 3x combines with a negative 10x and an x. So 3x and negative 10x is negative 7x plus x is negative 6x. The 12, the negative 12 combines with the positive 2, making it a negative 10. All over x minus 4, x plus 2, x minus 2. Can anything else reduce? Most likely not. And that's it. Are you done? No, you need the restrictions. What can't x be? X can't be 4, 2, and negative 2. Good job. Perfect, guys. How do you guys feel? So please write this down. This is example number 2. So write that down while you're doing this. This right here is example number 1. This is example number 2. Alright, in example number 2. That's it for today, but on my question bound below, I want you to find the answer. I want you to find the common denominator, just the common denominator. Do not add them up. What is the common denominator for this one and the second fraction in example number 2? So once again, for this one right here and the second fraction for number 2. I think that's a 6x, by the way. For this one right here and the second fraction for number 2. Alright, good. Write that down in the question below, and I'll check them and give you credit. Please do it, so you could get credit. Alright, have a good day. I'll see you whenever I see you. Alright, bye guys.